Have I? Oh, plenty of times. Yeah, sometimes the worst case is when I forget to do it and I'm halfway into the lecture and then somebody says, hey, are you recording? That's not the worst thing. The worst thing is when they say, yeah, I noticed in the beginning that you weren't recording. That, I was like, then why'd you wait 45 minutes to tell me? Like, what's, you know, so.
Is that every class?
Not every class. Oh, I mean, I record every class. I don't forget to start the recording every class. That's like a once a week. So number 2. Oh, and there's recordings from previous semesters if you want to get ahead of the game, you know, so you can just kind of follow along. So what we were doing here is finding the particular solution to a differential equation. And so it was already given in the appropriate form in number 1. In number 2, we have to sort of get it where we need it to go. So what we're going to say here is that g of x is equal to the antiderivative of, well, it would be the antiderivative of g prime of x, but we happen to know g prime of x is equal to 6x squared dx. Solution to a differential equation should be a function. So if your answer is not written in function form, it's going to cost you, but also once you see why it's written in function form, it's kind of like self-correcting anyway. What is the antiderivative of 6x squared? What is it? Oh, 2x? 2x, yeah. Plus c, yeah. So then, g of 0 has to be equal to -1. So we're going to say 2 times 0 cubed plus c is equal to -1. Yeah, this one's a nice one because, you know, you expect the problem to have a little bit more teeth, and this one really doesn't. So we're good there. It's going to give us c equals -1. Because we were plugging in a 0 for x, what we're dealing with here is called an initial condition. The previous case, it was just a condition. You're given an x or an x and a y, and it allowed you to figure out what c was. Here it's an initial condition because the x value in particular was equal to 0. All right. So if we're referencing time, that would be at time t equals 0. So when you're starting the clock. All right. But anyway, our final answer would be g of x is equal to 2x cubed minus 1. Hatched. So now let's kind of move along with this. The ball is thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet, using the fact that acceleration due to gravity is 32 feet per second squared. We want to find the position function. Now, we're going to kind of pretend, and for some of us, we're not pretending, but based on what you should know coming into the course, let's say everybody knew what they should have, like what you should know coming into the course. If that's the case, then I need you to pretend that you've never seen or heard of the position function. But like I said, in the case for some of you, that's actually a true statement, right? The idea here is to actually invent the position function. It's not to write down that position function that you learned in pre-calc and fill in some numbers. It's actually to see where that position function came from. Well, the fact that we're saying that it's gravity accounts for it being negative, so we'll slap the negative on when the time comes. As long as we know to do it, though, and that's a good point. All right? So, well, let's start with that. Let's start with the information that we're given. Acceleration, a of t, is equal to -32. We'll deal with units in due course, but for now, let's just focus on the numbers. All right. So it's a constant acceleration, right? The acceleration measure never changes, but it does impact how velocity changes, right? So, because what acceleration is the rate of change of speed or velocity. So if I'm saying that something is increasing, for example, at my acceleration is 2 meters per second squared, I'm saying the velocity is increasing by 2 meters per second every second. So if I start off at 0 meters per second, after 1 second I'll be at 2, after 2 seconds I'll be at 4, after 4 seconds I'll be at 8, and so on. So yeah. Oh, sorry, I'll be at 6 now. Otherwise that would get out of hand pretty quickly. You'd be going like 256 miles per hour after 8 seconds. Is 2 to the 8 256? 2 to the 8? Oh yeah, I wish I had a classroom full of people with calculators. Like that's my one wish in life. Yeah. It is? Okay. So I'd like to, at some point, try to do math mentally. Because it's in the downward direction. Right? So upward and to the right is considered to be a positive measure. Downward and to the left is considered to be a negative measure.
It's not x and y coordinates.
Exactly. Yeah, just like x and y. All right, so I got to work my way back to position. Prior to acceleration is velocity. So I'm giving you the relationship now, but I'll explain later on why the relationship exists. So v of t is equal to the antiderivative of a of t with respect to time. Not always, only if it's going down or to the left. Gravity will just go in the downward direction.
So that's why it's thought to be opposite.
Yeah, when dealing with gravity, absolutely. Yeah, because otherwise we could go in the other way, which would be fun. You know, for short bursts. Although, what was it? Despicable Me 1? I think it was that one where you had the minions, like you had an anti-gravity gun, so it reversed gravity and they started floating away. And then one of them went out the roof, and Dr. Nefario was like, "Oh, I meant to close that." And then it was like, "Well, does it ever wear off?" He's like, "Yeah, probably, I guess." And at the end of the movie, he's floating in space. Required also watch that movie. The second one wasn't as good as the first one. And they actually talked about vectors in that. The villain's name is Vector. So, was there a question?
Yeah. And it shouldn't be like started from here. And you see like, go down, yes.
Yeah, so it's starting off, I'll draw the picture, at a height of 80 feet. So like right here. Then it's going up in the air, and then gravity's always taking hold of it. And then it's working its way down. So we would actually have some maximum height other than 80, but that's where we're starting. And it's getting shot with an initial velocity. If the initial velocity was 0, then we would assume that it's just being dropped. Right? That's a little bit of a difference. All right, so we can find the antiderivative. To come up with the velocity function, we can find the antiderivative of acceleration, negative 32. And what is the antiderivative of negative 32 with respect to t? Negative 32, but with t. Right idea. Plus c, plus some constant c. All right. So let's carry that out to the next step. I'm going to rewrite, make it look a little nicer. Negative 32t plus c. Now, we have to figure out, because we have some conditions, we have to figure out what the c is going to be. And I'll show it algebraically, but you'll see after I show it algebraically that you don't really need to do algebra. It's saying that there's an initial velocity of 64 feet per second. All right? So that's telling me that when time t equals 0, your v of t is equal to 64. All right, so that allows me to plug in a 64 for v of t. Then plug in a 0 for t and solve for c. But you just get 64 equals c. Right? All the time when you plug in a 0 for t, anything that's got a t in it's going to cancel out, right? So in these cases, when you're dealing with a polynomial, in these cases, if your independent variable is equal to 0, then whatever that initial condition is, that is going to be your c value. You don't actually have to do the work. Same idea here, see? The c value ended up being -1. That's what the result of the expression was when you plugged in the 0. All right? So you can kind of save yourself some time. If not, you can show the work. I mean, it's never a bad thing. This is not the kind of thing where showing you work is going to cost you half an hour of your life. It'll cost you like 20 seconds. Okay, so it's totally fine to do it. Because when it's initial, that means that it's at the start. At the start, time is equal to 0. No time has passed. Anytime we say initial, that's the assumption that t equals 0. Correct. So then the next step is going to be to rewrite my velocity function as -32 t plus 64. All right. Now they said find the position function. I just found the velocity function. So that means we got to do it again. We got to find the antiderivative again. S of t, S for position, is equal to the antiderivative of the velocity function with respect to time. By rule. All right. So I'm looking at the antiderivative of -32 t plus 64 dt. And the antiderivative of that is equal to what? I think that's what. All right. So that's my S of t. Now, it says that we're working at an initial height of 80. So initial, again, t equals 0. Height, we're abbreviating with S. All right, so S of t would be 80 when t is equal to 0. So S of 0 is 80. 80 equals -16 times 0 squared plus 64 times 0 plus 80. And again, that's assuming you don't see that it's immediately 80 just by looking at it. Plus c, sorry. No. So c is equal to 80. And we have S of t is equal to -16 t squared plus 64 t, this thing is killing me. 64 t plus 8. Position function, yeah, S as a function of time. All right. So there you have it. That's your position function. Now, if you knew the position function, as I'll write it below it, S of t is equal to 1/2 gt squared plus VO t plus S, position of a free-falling object. Yeah, that's a physics rule. But you can just pop in your constants and you get this, because gravity is -32, half -32 is -16. The initial velocity is given as 64, the initial height is given as 80. Right? But it turns out that this formula comes from this process. Right? Physics didn't inform the mathematics. The math informs the physics. Right? That rule doesn't exist without the concept of an antiderivative. And in all honesty, if you've taken a physics class and they didn't address this kind of concept, it's because the physics course that you took didn't have calculus as a prerequisite for it. So they didn't think that the folks in the class would necessarily understand what the hell they were talking about. Well, with the calculus background, you can see where this formula comes from. In fact, I could show you real quick. It's kind of cool. Actually, I'm going to show you a couple things real quick. If I'm saying that A is equal to gravity, the acceleration constant due to gravity, I was using A of t, so I'll say A of t. Then V of t would be the antiderivative of g dt, which would be 1/2. Oh, actually, no, not there yet. It's like accidentally telling the punchline to a joke too early. It's just gt plus c. All right. Now, this would be, we would have an initial condition. So the initial condition would be when time t equals 0, you have some initial velocity. You have some velocity associated with that, which we'd call v of 0. So basically, I'm coming up with an ordered pair of 0, v of 0. Which should make some kind of sense, a little bit anyway, because it's basically saying, I don't know what the velocity is, but when t is equal to 0, I'm going to have some velocity corresponding with that t equal to 0. All right? I just don't know what it is. So this is saying, I will have a velocity at time t equals 0. I just don't know what it is. All right? So then when you plug that in, you would have v of t becomes VO, g times 0 plus c, making your c equal to VO. So when all is said and done at this point, you get v of t equal to gt plus VO. And that's a variable velocity formula for a free-falling object. You have some velocity that's impacted by the product of gravity and the amount of seconds that have passed. Okay? So if you're talking like you have an object that's already going downward at 20 meters per second, so -20, and you're on some fictitious planet where acceleration due to that gravity is 10, then every second its velocity is going to increase in the negative direction by 10 meters per second. So I started at -20, it would go to -30, then -40, and so on. Right? This formula will bear that out. Right? It's a linear model, and in this kind of situation, velocity tends to follow a linear model. Right? When it's not free falling, when acceleration is not constant, then you can't make that assumption. Right? So S of t would be equal to the integral of gt plus VO dt, which would be, this is where we're getting the 1/2 gt squared plus VO times t plus c. And here we're saying that we have some coordinate 0, s of 0, by the same reasoning above. At time t equals 0, I have some velocity associated with that. I could even say something like 2 comma s of 2. After 2 seconds, I have some, not velocity, but position associated with 2 seconds passage of time. But that's not the case. So SO equals 1/2 g t squared plus VO times 0 VOT plus C. And then we get C equals SO. And now we have our position function, which was in fact invented by calculus. And you're like, oh, I want to use a physics formula. There is no physics formula. The physics formula was all invented in math.
Yeah, we just did these, but they never explained it.
Yeah, because they couldn't trust that you would know the calculus behind it. It's crazy, and this is kind of like self-deprecating. Not to serve a purpose, but physics teachers, they're some of the best math people that you'll ever meet. Like when you actually talk to them, they're like, oh, but you're a science person. They're like, no, in order to be a physics person, you have to be a math person first. You got to know the calculus. And then after that, physics comes. So, it's never ending. And I'm learning even more as I go, because I'm not a physicist, but I do like the math, and I'd like to know where it goes. And to integrate along a rod, for example, that's like a current flowing through a wire. So when we talk about integration over an interval, and that interval is cylindrical, what we're trying to do is model things like water's passage through a pipe or a current's passage through a wire. Okay, so the physics applications of it are almost non-stop. That's crazy. The second part of this problem, when does the ball hit the ground? That's just algebra. We did this. All this was the calculus. This is the fun stuff. Back there is like, all right, wait. So I just got to find out when its height is equal to 0. So I have my function -16 t squared plus 64t plus 80. I'm going to set that equal to 0 and solve. So that's algebra 2, college algebra, trig, pre-calc, that kind of neck of the woods. So the calculus part is over. The reason, this is kind of like a teacher trick, the reason anybody ever asks about a follow-up like this is so that I could have a quick way of spot checking to see if your answer was correct before I start diving in looking for partial credit. Because if you get part B right, you are working with a correct equation, which as long as the work supports that, and you probably did everything right, it just makes my life easier in terms of grading. I'm able to grade things quicker. It doesn't serve any mathematical purpose, though, really, because you can get it off your calculator. Speaking of calculators, I'm going to show you how to write a program in a couple minutes, but we'll do this one algebraically real quick. All right, so we have a common factor of -16. T squared, that would be -4t plus 5, minus 5, equals 0. You can disregard the -16, it's constant multiple, it divides out. T minus 5, t plus 1, I believe. So we get t equals 5 or -1. So this is saying that the ball is thrown upward with an initial velocity. Okay, so it already started at a particular height. If I kind of extrapolate that backwards, I get that -1. That's over here. That's irrelevant to the situation. There's a time and place for negative time. It actually, there are circumstances where it does make sense to have a negative time. This just isn't one of them, because the clock started at 0. It wasn't like we allowed for any motion prior to the time t equals 0. At 5, That gives us the relevant point. So after 5 seconds. But I can't remember if it's in this course. I had a problem. It involved an elevator. It might be in this course. I think it's this stuff. But in that case, negative time made sense because if you're standing on, let's say, the 30th floor and the elevator's coming downward, you could have a negative time. Negative time is just at some floor above you before it got to you. Positive time is after you, assuming you're starting the clock when it passes your floor. Right? So there is a case to be made. It's just a question of will that negative time answer the question that you're being asked? Maybe, maybe not. It depends on the situation. Right? But definitely don't just dismiss a number because it's negative. Right? You'll pay a price at some point. Maybe not today. Maybe not tomorrow.